Today we will discuss a theorem from group theory which says that G is a group of order PQ where P and Q are distinct primes and P is strictly less than Q and P does not divide Q minus 1. Okay. Then G is abelian. Not only abelian, from here we can show that G is also cyclic. Okay. ये थ्योरम बहुत ही इंपॉर्टेंट थ्योरम है, पर मैं ये थ्योरम साइलोस थ्योरम की हेल्प से प्रूव नहीं करूंगा, बिकॉज साइलोस थ्योरम से अगर प्रूव करें तो ये बहुत ही आसान हो जाएगा। पर अगर हम किसी दूसरे मेथड से जाए, मान लो मैं इसको प्रूव करने वाला हूँ आज ग्रुप एक्शन और क्लास इक्वेशन की हेल्प से, तो ये बहुत ही इंटरेस्टिंग होगा, बहुत कुछ सीखने को भी मिलेगा। ठीक है, तो हम प्रोसीड करते हैं। ओके, तो ऑर्डर ऑफ जी हमारे पास गिवन है पी क्यू, वेर पी एंड क्यू आर डिस्टिंक्ट प्राइम्स। मैं लिख नहीं रहा बार बार, एंड पी इज लेस देन क्यू, स्ट्रिक्टली लेस देन क्यू, पी डज नॉट डिवाइड क्यू माइनस। नाउ वी ऑलरेडी नो that ZG is a subgroup of the group G. So by Lagrange's theorem, order of ZG divides order of G, right? So possible order of ZG क्या क्या हो सकता है? So possible order of ZG are one, either one, or P or Q or PQ, right? Okay. Now तो इन ये सारे चॉइसेस हैं। ओके, recall the G by ZG theorem. Okay, what is that theorem? That if G is a finite group and G by ZG is cyclic, this implies G is abelian. Okay, so order of if order of ZG is P, then order of G by ZG is what? Is Q, right? Is prime. This implies G by ZG is cyclic. This implies G is abelian, right? So we are done. Okay. If order of if order of ZG is Q, then also we are done. If order of sorry, if order of ZG is PQ, then what? This is same as order of G, right? This implies ZG is whole G. This implies every element commutes with each other, right? This implies G is abelian automatically. So in all these three cases, we are done, right? In all these three cases, we are done. Now the only possibility is order of ZG is 1. Is it possible? Is it possible that order of ZG is 1? My claim is not. It is not possible. Okay. We will prove this claim. Claim order of ZG cannot be 1. Okay. That is ZG cannot be trivial. Okay. Now how can we proceed from here? By contradiction. Okay. If possible, order of ZG, we take it 1. Okay, हम मान लेते हैं कि ZG का order 1 है. This implies ZG is trivial, right? only identity element is there. Okay. Now uh, now assume every non identity what I'm writing, every non identity element in G has order p. ये मैंने मान लिया, ठीक है. Now assume every non identity element in G has order p. Okay, we will show that it is not possible. Okay, now first of all assume that every non identity element has order p. Okay, then let x belongs to G such that x is not equal to identity. Then what happens? Then order of x is what? Order of x is p, right? Let's say we generate a subgroup by this element x. Okay, let h be the subgroup generated by x. Let I will use the h later, so let it will I will take this as h dash. Okay, I denote this subgroup by h dash because h I need later. Subgroup h I need later because in mathematics notation are very important. Okay, so order of x equals to p, and the subgroup generated by this x has order also p, so order of h is also p. Okay, order of h dash is also p. Okay, now consider the centralizer of h in G, h dash in G. Okay, that is what it is. G belongs to capital G such that G h G inverse equals to h for all h belongs to what? H dash. For all h belongs to h dash. Okay, now observe that this element x, this already belongs to h, right. So I consider the centralizer of h in G. So x belongs to centralizer of centralizer of h in G, right. Sorry, this will be h dash. Okay, centralizer of h dash in G. Okay, so since x belongs to centralizer of h dash belongs to G, this implies what? This implies what? This implies the subgroup generated by x, this h dash, it is fully contained inside the centralizer of h dash in G. Okay. Now since h dash is a subgroup and it is contained inside CG h dash, this implies h dash is a subgroup of CG h dash, right? Centralizer of h in h dash, h dash in G. So order of CG of h dash, this is what? This will be either p or greater equals to p, right? Since this h dash is contained inside what? The centralizer of h dash in G, right? And it is a subgroup, we know. Subgroup till now, before that we know that it is a subgroup of G, right? Now we see that this is inside CGH dash. So it is a subgroup of CGH dash. So subgroup of CGH dash means what? Its order divides must divides its order, right? It is also a subgroup. So its order is P, we know that. So at least the least order of CGH dash is possible is P, right? Either P or more than P. So we take order of CGH dash is greater equal to P. So is it possible that order of CGH dash is strictly greater than P? Let's check. If possible, let's check. And we also have P is less than Q, right? So it is also a possible case. So if order of CGH dash is strictly greater than P, then what are the possible orders of order of CGH dash? What are the possible orders? So possible orders are either Q or PQ, right? These are the only possible orders. Okay, okay. Now, mm, now what? Now, uh, hmm, hmm. Now, if order of CGH dash equals to Q, right? Then what happens? Then what happens? Then uh, we know that H is a subgroup of CGH dash, right? Okay, H is a subgroup of CGH dash. This implies what? And we take this is of order Q, right? This is of order Q, right? This implies H is a subgroup of CGH dash. This implies by Lagrange's theorem order of H divides Q, right? And order of H is sorry, it will be H dash. Okay, so order of H dash will be divides Q. So P divides Q, right? But it is a contradiction because P and Q both are prime, right? And P is strictly greater than Q is strictly greater than P. So how can it divide? How P can divide Q? It is not possible, right? So order of CGH dash cannot be equal to Q. Okay. So only possibility left is so order of CGH dash. So let order of CGH dash is PQ. Okay. This implies order of G. This is equals to order of G. This implies the CGH dash is nothing but the whole group G. Okay. This implies every element of G, every element of G commutes with every element of every element of H dash, right? CG H dash is what? CG H dash is what? Those G belongs to G such that GH equals to HG, right? For all H belongs to H dash. You understand, na? This is definition. And we have CGH dash is whole G. So every element of G commutes with every elements of H, right? Okay, we get this, right? Okay. So can you see the contradiction from here? That is it not? It is not possible. It is not possible since X belongs to CGH dash, right? We have X belongs to CGH dash, right? This implies what? X commutes. Sorry for the mistake. X commutes with every element of G. Is it correct? See, every element of G commutes with every element of H dash, right? तो इसका उल्टा क्या होगा? Every elements of H is commute with every elements of G. तो समझ आ रहा है मैं क्या कह रहा हूँ कि मान लो कि G belongs to G है, कैपिटल G है और स्मॉल H belongs to कैपिटल H डैश है. ओके, तो मैं कह रहा हूँ कि G H डैश के H के साथ कम्यूट करता है, ये G H के साथ कम्यूट करता है. इसका मतलब तो और एक भी है ना कि H G के साथ कम्यूट करता है, राइट? तो वही कह रहा हूँ कि every element of G commutes with every element of H dash. This implies in particular this X also commute with every element of G, right? This implies what? See, this X belongs where? If any element of G commute with every elements of G, then that element belong where? That element goes to ZG, right? But ZG is what? Singleton set identity. This implies X equals to identity, but it is a contradiction because we take X as a non-identity element, right? So order of the CGH dash cannot be PQ, right? Cannot be PQ. Okay, this implies order of C order of CGH dash has to be P, right? Because the only possibility left is P, so it has to be P, right? So greater than P is not possible. Not order of CGH dash is Q is not possible. PQ is not possible. So only possibility left is P. Left is P. So order of CGH dash is P. Okay. Now, okay, we get this. Okay. So from here, what can you say about the conjugacy classes order? What can you say? Can you say anything from here? I think you can, right? Since order of CGH dash has order P is of order P, so every conjugacy class has order what? Every conjugacy class has order Q, right? It has to be Q, right or wrong? Why? Why? Because any conjugacy class, uh, any conjugacy class, let's say this is a conjugacy class. This is what? This is order of this conjugacy class is nothing but order of G by order of C G of alpha, right? Okay. So we have every for uh, mm, CGH dash or order of CGH dash is P, right? So for every element, for any non-identity element, we can do this. For any non-identity element, we can do this, right? I take a non-identity element X from G and we show that order of CGH dash is P, right? So for any non-identity element, we can do this. So order of CGH dash equals to P. This implies what? Index of CGH dash in G is Q, right? This implies every conjugacy class has order what? Order Q, right? What is the index here? The index is order of G by order of CGH dash equals to Q, right? This is the order of the conjugacy class, right? This implies uh, every conjugacy class G has every conjugacy class in G has order Q, right? Every non-trivial because ZG is trivial, right? So its conjugacy class will be no, sorry. Okay. Till now we have this. Okay. Now what we have, therefore from this what can we say? Therefore order of G equals to 1 for plus K times Q, where K is an integer. How I can write this? Because order of G equals to ZG plus summation A does not belongs to ZG, order of G by order of order of G of A. Okay, right? So ZG in our case ZG is trivial, right? So for ZG it is 1. For order of ZG, sorry, order of ZG is 1. Okay, and plus this conjugacy class, order of conjugacy class, each conjugacy class, right? So each conjugacy class has order Q, right? Okay, then how many conjugacy classes are there? I don't know. There are some conjugacy classes, so I take, for that I take K, right? So for every non conjugacy class we have order Q. So let's say there are K many conjugacy classes. So the total number of conjugacy classes of order q is kq, right? Okay. Now, uh, now, so from here, what can you see? PQ, order of G is PQ, right? That is PQ equals to 1 plus KQ. This implies what? This implies PQ minus 1 equals to KQ, right? Then, mm, then this implies Q divide PQ minus 1. Is it possible? Okay, see, PQ is equals to 0 mod Q, right? That you understand, because Q divides PQ, right? Okay. Now PQ minus 1 is equals to minus 1 of mod Q, right? It cannot be equal to PQ minus 1 equals to 0. Cannot be equals to 0 mod Q, because it is minus 1 mod Q, right? Cannot be equals to 0 mod Q. So how Q divides PQ minus 1? Q divides PQ minus 1 means PQ minus 1 congruent to 0 mod Q, right? So this is a contradiction. This is a contradiction, right? तो कॉन्ट्रडिक्शन हमें क्यों मिला? हमें कॉन्ट्रडिक्शन क्यों मिला? क्योंकि हमने मान लिया था कि एवरी एलिमेंट ऑफ जी हैज ऑर्डर पी, एवरी नॉन ट्रिवियल एलिमेंट ऑफ जी हैज ऑर्डर पी. सो आवर सो हमने क्या देखा कि क्यों ऑर्डर, मतलब हमने क्या 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 चॉइस लिया था हमने ऑर्डर ऑफ सी जी एच डैश के लिए. एक था P, एक था Q और एक था PQ. तो हमने देखा कि ये नहीं हो सकता, ये नहीं हो सकता, और तो हमने मान लिया था कि शायद Q P होगा, P होगा, राइट? तो P भी होने से यहाँ पर कॉन्ट्रडिक्शन मिल रहा है हमें, राइट? ये Q PQ माइनस 1 को डिवाइड कर जा रहा है, पर ये तो पॉसिबल ही है नहीं, राइट? सो ऑर्डर ऑफ सी जी तो ये भी नहीं हो सकता, तो ऑर्डर ऑफ सी जी एच डैश होगा क्या? तो इतने सारे कॉन्ट्रडिक्शन आने का मतलब क्या है कि हमने जो एज्यूम कर लिया था कि एवरी नॉन ट्रिवियल एलिमेंट ऑफ जी हैज ऑर्डर पी, ये गलत है, राइट? और assumption is false. This implies there must exist an element of order q, right? Of order q. Okay, there must exist an element of order q. ठीक है. Let G belongs to G such that order of G equals to Q. Okay. Now consider the subgroup generated by G. Call it H. Okay. So order of H what? Order of H is Q. Order of H Q हो जाएगा. ठीक है. And uh, index of H in G is what? Index of H in G is nothing but P, right? And observe this, P is the smallest prime dividing order of G, right? P is the smallest prime dividing order of G. And recall that theorem, that a theorem which is a very important theorem in group action, that uh, if P is a smallest prime dividing order of G, smallest prime dividing order of G, then any subgroup of index P is normal. Okay, any subgroup of index P is normal. Okay, so here is what happening. Order of H is Q, and what we see that order of the order not order the index of H in G is what? It is P, and P is the smallest prime dividing order of G. Therefore, what it implies? It implies H is normal, right? By that theorem, by this theorem, H is normal in G, right? Okay, so we get a normal subgroup of order Q. Okay, it is a normal subgroup in G of order Q. Now consider the group action by conjugation. By sorry by G cross H defined by G comma uh, G comma H goes to G dot H, where is this dot is the action. Okay, action of G on H, that is G dot H equals to G H G inverse. This is defined, right? That is G H G inverse belongs to H, right? For any G, since H is a normal subgroup, right? Okay, so this action is defined. Okay, now for every action we have a induced homomorphism, and since this is a induced homomorphism by via permutation representation, right? And since this is a what I say, since this is a conjugation action, that's why these homomorphisms, these permutations are not only permutations, they are uh, automorphisms, right? Because of this conjugation. So we can write this this action gives uh, an homomorphism from G to automorphism of H, right? From is cardinality. Okay, automorphism of G, homomorphism from G to automorphism of H, right? Since these permutations are not only permutations, since we are working on conjugation action. Okay, okay. How the map is defined here? G goes to phi suffix G, where phi suffix G is a map from H to H defined by phi G of H equals to G H G inverse. Okay, just check it. What I am saying, it is satisfies or not for this. That permutations are not only permutations, it is indeed a automorphism. Okay. Okay. Now what I need to show, what I need to find is kernel of this homomorphism. Let's call this map as capital phi. Okay. Then kernel of this capital phi is what? All such G belongs to G such that phi of G is the identity automorphism, right? That is, those G belongs to G such that uh, phi suffix G equals to identity. That means those G belongs to G such that phi G of H equals to H for all H belongs to capital H, right? This implies those G belongs to G such that GH G inverse equals to H for all H belongs to H. This is what? This is nothing but the centralizer of H in G, right? So what we get, the centralizer of H in G is the kernel of the homomorphism, right? So this centralizer is a normal subgroup since it is the kernel. Now observe that order of H is what? It is Q, right? So it is cyclic. Not only cyclic, it is, since it is cyclic, so it is abelian also, na? So H is abelian also, and H is contained inside CGH, right? So H is a subgroup of CGH. Okay. So content inside CGH, so it is a subgroup of CGH. Since it is abelian, so it contained inside CGH. Okay, so H is a subgroup of CGH. Okay, since order of H is Q, so order of CGH is greater equals to Q. So it is greater equals to Q means what? Either it is Q or it is PQ, right? But it cannot be PQ, right? If it is PQ, then if then the similar argument will happen, then that every element of G commutes with H. Then conversely, every element of H commutes with every element of G. Therefore, ZG cannot be trivial. So order of CGH cannot be PQ. Okay, since we see previously that order of CGH is not equals to PQ, so order of CGH equals to Q. Since H is a subgroup of CGH which has also order Q and CGH is also order Q, this implies CGH is nothing but H. Okay. Now use the first isomorphism theorem. We have a homomorphism from G to what H, right? Okay, one more observation. What is that is order of G is Q, right? Q is prime, so H is Q is prime, so H is isomorphic to ZQ, right? And I think you know that automorphism group of ZP, where P is prime, is isomorphic to what? ZP cross, right? That is UP. So order of automorphism group of ZP equals to P minus 1, right? Because it is of order P minus 1. Understand, right? Okay. Now we have a homomorphism from G to what H, and the kernel is CGH, right? So by first isomorphism theorem, we have what? G by kernel of capital Phi is isomorphic to capital Phi of G, right? That is subgroup of aught of H, right? Automorphism group of H. Okay, this implies G by Cg of H is isomorphic to Phi of capital G, that is sorry, not isomorphic. That is a subgroup of automorphism group of H, right? Okay, and we see that automorphism group of H is nothing but it is isomorphic to ZQ star, right? ZQ star, right? Okay, it is prime. Okay, ZQ star. Since order of H is Q and Q is isomorphic to ZQ, and automorphism group of ZQ isomorphic to ZQ cross. Okay. Okay. Now, um, now I think you can clearly see the contradiction, right? That order of G by order of CGH equals to what? Equals to Q minus 1, right? This group has order Q minus 1. This implies uh, mhm, wait, order of G by order of minus 2, it has to be order of I of G, right? And it will divide Q minus 1, right? Because this is a subgroup of this, so it has order Q minus 1. So order of I of G divides Q minus 1, right? Okay. Now what is order of G by order of CGH? CGH has order Q and order of G is PQ. So this is P, right? This is P, right? Okay. P, P equals to order of I G that divides Q minus 1. So like P divides Q minus 1, which is a contradiction, right? That the hypothesis tells us that P does not divide Q minus 1. So we get contradiction. Why? Because we take order of Zg is 1, that is Zg is trivial. So our assumption is wrong that order of Zg is no, trivial. So order of Zg cannot be trivial. Okay, so order of Zg cannot be singleton set identity. This implies G is Abelian. Okay. Now, how can you conclude that G is cyclic also? How can you conclude? Let A belongs to G such that order of A equals to P and B belongs to G such that order of B equals to Q, right? Okay. Oh, first of all, how can you um, मतलब मैं कहना चाह रहा हूँ कि तुम्हें कैसे पता चला कि ए ऐसा एलिमेंट मिलेगा ए और बी सच दैट ऑर्डर ऑफ ए एंड ऑर्डर ऑफ बी पी एंड क्यू हो इसका गारंटी कौन देता है इसका गारंटी देता है कॉचीज थ्योरम राइट फॉर एवरी prime divisor there is a prime divisor of the group there is a element of that order right so so not okay. Now since G is abelian this implies AB equal to BA right this A and B commutes okay now P and Q are what P and Q are prime right so they are co-prime right P and Q are co-prime okay so you know a theorem which is a very basic theorem that if G is a group and A and B both element of G such that A and B commutes and order of A and order of B are relatively prime then order of AB is nothing but order of A into order of B okay I will write it again if G is a group and that is recall it is a proposition that if G is a group and A comma B belongs to G such that AB equals to BA and order of A and just write it GCD of order of A order of B equals to 1 then order of AB is what order of AB is order of A into order of B okay so here all the things are satisfied right A and or GCD of A and GCD of order of A and order of B is 1 and A and B are commutes right so what can we say from this proposition that order of AB equals to order of A into order of B right that is P into Q since A comma B belongs to G since G is a group so AB also belongs to G and AB has order PQ right AB has order PQ this implies what this is equals to order of G na? This implies G is generated by AB this implies what G is cyclic easy right so if we do not use the Sylow's theorem to prove prove this theorem then it is very lengthy but it is very interesting right बहुत कुछ सीखने को मिला यहाँ से कैसे क्या अप्लाई करें कहाँ से कहाँ पहुँच रहे हैं हम ग्रुप एक्शन कैसे अप्लाई करें ऑटोमॉर्फिज्म ग्रुप का कुछ प्रॉपर्टी ये सब बहुत सारी चीज़, तो ये बहुत बहुत ही यूज़फुल थ्योरम तो बहुत ही यूज़फुल है ही, पर ये प्रूफ भी बहुत यूज़फुल है। ठीक, थैंक यू।